Let's dive right into this explainer. Today, we're looking at a deeply mesmerizing phenomenon. It's something that, honestly, to the untrained eye, looks entirely impossible. We're going to explore why superfluids are absolutely not magic and what exactly happens when matter simply forgets friction.
A liquid climbs the walls of its container. Just picture what that actually means. You have a polished glass container, and sitting perfectly still inside it is a cold, luminous liquid. Without any pumps, without any shaking, a razor-thin film just begins creeping up the inner wall, slowly flowing right over the rim. It is a hypnotic, completely impossible-looking movement. It's like gravity has suddenly become a suggestion rather than a hard rule.
And it doesn't stop there. It slips through tiny gaps. We are talking about microscopic channels here, pores that ordinary liquids simply cannot penetrate. Water or oil would get completely trapped. But this cold, pale quantum fluid, it effortlessly passes right through. It moves silently, gracefully, and with a flow that appears to be completely frictionless.
Naturally, when you observe a fluid flowing with effectively zero viscosity, it looks like magic. It feels like a literal magic trick because it breaks basically all of our everyday intuitive experiences with matter. We're used to things slowing down, right? We're used to resistance. So seeing a liquid display this kind of persistent motion, doing things that look suspiciously like anti-gravity or perpetual motion, it plays tricks on the mind.
But superfluidity is not magic. That is the core thesis of our entire explainer today. We aren't looking at fantasy portals, we aren't talking about magic spells, and we certainly aren't looking at broken laws of physics. Instead, we're looking at a mathematically and geometrically precise behavior of matter. It's really one of the clearest signs that our universe operates by rules that, under very extreme conditions, actually allow matter to stop acting like a disorganized crowd and start acting in perfect, elegant harmony.
Section 1. Quantum behavior stops hiding. Everything hinges on a very specific extreme temperature, 2.17 Kelvin. In physics, this is known as the lambda point. Now, accepted physics shows us that superfluidity appears in certain systems, most famously helium-4, when the temperature drops near absolute zero. At that point, helium atoms stop acting like hard, separate billiard balls bouncing off each other. Instead, drop them below 2.17 Kelvin, and they soften into these wave-like forms, overlapping and settling down into an astonishingly frictionless state.
When matter gets cold enough, quantum behavior stops hiding. Think about the gravity of that for a second. Normally, quantum mechanics is entirely locked away at the microscopic, invisible scale. We just don't see it with the naked eye. But here, the extreme cold calms the chaotic thermal noise so perfectly that those tiny hidden quantum effects suddenly become visible at the macroscopic scale of the fluid itself.
This phenomenon has a name. It's called macroscopic quantum coherence. And what's really interesting here is how it completely demystifies the whole thing. It proves we are dealing with a heavily documented, real quantum state, not some mysterious energy from nowhere. The atoms get so cold that their individual identities basically blur together, and they begin to behave as a single coherent entity. It is an elegant, collective state that is entirely permitted by the laws of thermodynamics.
Section 2. Ordinary fluids pay friction.
The contrast here is just brilliant. Think about ordinary liquids. They act like a messy crowd of particles. When they flow through a pipe, they shear against each other, they create drag, and they lose their organized motion as heat. Their movement is heavily taxed by resistance. But the superfluid, it has shared motion. It drops into a collective low-cost basin, finding a single coherent route where all that messy dissipation simply fades away into a smooth, silent flow.
So let's clarify what's actually happening in this low-friction state. The superfluid route does not overpower the wall by brute force. It doesn't break thermodynamic laws, and it absolutely does not rely on free energy. The crucial point here is that the fluid hasn't overpowered the boundary at all. Rather, it has accessed a low-cost coherence basin. The usual pathways that create drag and heat, they're simply no longer available to it.
A superfluid does not overpower friction. And this brings us to an exploratory geometric lens known as General Emergence Mechanics, or GEM. In this framework, we interpret the phenomenon as a route-cost collapse. It's not a scenario with two opposing forces where the liquid suddenly wins a wrestling match against the pipe. It's that the underlying rules of engagement have geometrically shifted.
It enters a route where friction has almost nothing left to tax. Now, to be clear, this zero-cost route is a metaphor for an extremely low dissipation state. Think of the fluid finding a perfectly smooth geometric path that reality permits. Because the particles are locked in macroscopic quantum coherence, those tiny individual collisions that normally get heavily taxed by friction, well, they just aren't happening anymore.
This is matter behaving less like a crowd of particles and more like a single admissible route. Matter shifts from separate, colliding entities into one continuous, unbroken wave. It's no longer negotiating local roadblock after local roadblock. It has united. It has become one shared, coherent trajectory.
Now, I want to be absolutely clear here. This is not a replacement for quantum mechanics, a geometric question beneath it. General Emergence Mechanics deeply respects mainstream condensed matter physics. Helium-4 behaving this way is a well-recognized quantum fact. Modal theory simply asks us to look at this same fact through an exploratory geometric lens. It asks what superfluidity reveals about admissible routes, resistance, and the underlying persistence cost of moving through space.
Resistance is not always beaten. Sometimes the route changes until resistance has almost nowhere to appear. Let the deep mathematical weight of that statement sink in for a moment. It fundamentally changes how we view obstacles in the physical universe. Brute force isn't the only way to achieve persistence. Sometimes profound alignment and perfect coherence simply render the resistance irrelevant.
Section 3. Coherence made liquid.
Coherence made liquid. It's the ultimate, poetic summary of everything we've looked at today. This perfectly quiet, freezing, impossible-looking fluid climbing over a glass wall is really just the visible manifestation of absolute unity. It is the universe showing us exactly what it looks like when a system stops fighting itself and flows entirely as one.
Which leaves us with this final, truly provocative thought. If cold helium can collapse the cost of friction and slip through solid-looking walls by simply finding a more coherent route, what else could route cost collapse reveal about the hidden geometry of matter in our universe? If coherence is the ultimate key to bypassing resistance, what other impossible things might just be matters of perfect geometry? If you want the written foundations behind this series, the books, papers, and playlists are linked below. The videos are the gateway. The books and papers are the foundation layer.